The present value of single amount. In the last section, I introduced how to calculate future value of an invested amount. So the formula was FV equals invested amount multiply this. And I, we know that's invested capital, which also represents the value of this investment at present. We can replace I with present value. Then we can convert this equation to this one. If we are given an amount of cash flow in the future, we can use this formula to calculate the value at present. So this is a formula for the present value of cash flows. Based on the 3 years, 10% per year interest assumption, if the present value or invested capital was $1,000 today, it will become $1,331 by the end of year 3. Or we can also use this formula to calculate the present value of $1,331. Based on the same assumption, we know its present value is $1,000. Based on the rate and number period, $1,000 future value is $1,331. The present value of $1,331 was $1,000. We can also use this table, the present value factor, for the single amount. You will see all these factors are less than 1 because they are present value factors. According to this, the present value factor actually is PVF. Its formula is this. This is always less than 1. Then we can look up the period 3 and interest per period 10%. So 0.75131 was the present value factor. We multiply the amount of cash flow by the end of the 3rd year. Its present value was $1,000. In other words, we can use both future value and present value formulas to calculate a cash flow's value at different time point. For comparison, we cannot compare a cash flow just based on their face amount. We should also compare the cash flow at the same time point. In other words, we cannot say $1,331 by the end of year 3, it has greater value than the present value than the $1,000 today, because these two amount of cash flow were on different time point. What we should do is we either calculate the present value of this cash flow and compare with this one, or we can calculate the future value of this cash flow and compare with this one. But we know these two are actually equivalent when we're accounting for the time value of money. $1,000 at present equals to $1,331 by the end of year 3, according to this assumption, 3 years, 10% per year. This example, I think there was an error in the slides. This should be 740. So you have two options, one 740 at present or 1,000 3 years later. So how to make this choice? If you don't account for the time value of money, you may think, oh, $1,000 was a bigger number, so why I will prefer 1,000. But actually, no, we should not compare the two amount of cash flow at different time point. What we do is we convert the 740 to the future, or 1,000 in the future to present. Then we make the comparison. First, if the 10% annual rate for 3 years, the interest is compounded annually. So the 7,400 now will be accumulate to $985. That means the future value of 740 will be $985, which is less than the other option, $1,000. So then you may prefer the second option because it has greater value. But if the interest rate was 11% or higher, the 740 now will be accumulate to a greater value because higher interest rate. So 740 will be $1,012.05 3 years later, which will be greater than another option, $1,000 at the end of year 3. So then 740 will be preferred under this assumption. So based on this agreement, we are asked to calculate the price of the truck. The price of the truck is actually the price on February 1st, 2024, which is unknown. But we know the company can pay $44,000 next year. So $44,000 will be the future value. So we should discount this cash flow or calculate its present value. So we should use the future value based on this formula, multiply the present value of $1, present value factor. The answer will be B.